Never used.
No. What Kahoot?
But
Kahoot is a quiz, but then something like a gamified quiz. You haven't used it. Okay, let's see. My diploma student mentioned that they like Kahoot because it's fun. I remembered I always give you all quizzes for web design, right? But then that one I use Google Form. Let me see. Yeah, I've created a game, a quiz using quizzes instead of using what do you call that? Kahoot. So let me go to my okay, one moment. And log in first. Okay, I believe the one that I share is the what is this? This is a 10 question, a gamified quiz to engage learners. Okay, so you can go ahead. Okay, let me see. Oh, invalid code. One moment. I think it's I need to do it one more time. Information system introduction. Okay, I think it's this one. Okay, now I know. First time for me to use this. So let me, tukar lah. Okay. So let me give you the correct link. Okay, so I've already said it, so I can try. It's 10 questions and then see how you.
okay.
So you just click start and then you can try. Farah and Noel already in. How about Kelvin? Kelvin is in. Okay, you can go ahead and try. Mm. So today is Kelvin. Okay, good. All right. So, oh, in fact, can see the score. Question 5. Question 5 is what? But then I'm not sure whether you all have the same sequence. ATM is a TPS. This one is actually true. Okay. And then question 6. Question 6. Which of the following can provide regular information about the daily activities of a business to managers? Or daily activities. Daily activities. What should be the answer? I believe it's TPS or MIS. Where can I see the answer? There's no button here. And then what else? Question 9. Oh, question 9. What is question 9? Oh, all of you got this one wrong, is it? The keyword here is forecast. Okay, forecasting future trends. This is an unstructured decision, and only the senior management deals with long-term decision making. Forecasting is one example, so it should be ESS, Executive Support System. And what else? Question 10. Okay, question 10 is, oh, in fact, I can just click here, right? Oh, okay. In the data, IS can are used to help plan delivery of goods and services. Delivery, it should be transportation industry. Oh, this is cool. I think I like this. How about you guys? Do you like this?
Oh, yeah.
Yeah. Got power also.
Yeah, I see they give meme. Apa lagi? There's a power up, and then there's a redemption question also, correct? For the question that you got wrong. Okay, so I'll try to create my own. That one is in fact done by other people who cannot. Okay, done by other people, whereby I can use other teacher lecturers quiz. Okay, and then I chose the first one because it has already been played like 2,000 times. Next time then I will give you, I believe I've added in here introduction to SDLC lah. Okay, perhaps next week. Okay, next week this one I created on my own. Okay, so I think let me go out from here and we'll continue with the lecture. Okay. So now it's week 6 already, and then last week we have covered the system and interface design, right, up to the report design, and today it's all about database design. So it will touch a bit on what we have covered in chapter 3, which is the system analysis, where you all have covered DFD and ERD. ERD would be the logical diagram for the database design. And in week 6, we will look at how we create the database based on the ERD, which has been prepared in the system analysis phase. Next week, week 7 is the procedural design. Procedural, we will cover decision tree, decision table. Okay, so that is our weekly plan. And what else for the tutorial? For the tutorial, there are 3 questions. So the first question, I'm sure you all can answer this. PK and FK. Question 2 is drawing of ERD, and then need to list the attributes. Okay. And then question 3, we will focus on this one. This is the second part of our lecture. Design the code for the PK. Remember here in your ERD, you have your PK and also FK, whereby FK is the PK from another table, right? We have the PK for the master file, PK for the transaction file, like order transaction, right? Perhaps your sales order number is 000010002. Okay, are we going to create a unique format for your PK, all right, or just simply use random numbers or simply use sequence number. So that is what we're going to cover for this one. Okay, the coding scheme. Here, coding scheme or the code design, we are not referring to the coding as in programming. Programming will be in which phase? A system development phase. We are still in the design phase. Okay, so that is the tutorial 3 questions. So one each lah. Later I will assign to you. And as for the case study, it will cover okay, FDD we have already covered, as well as input design last week. Oh, okay, the one that okay, the ERD you have learned in chapter 3. You need to resolve the many-to-many relationship. So for today, continuation would be in week 11. Okay, the data definition. So based on the ERD created, just need to list relevant attributes. Already resolved many-to-many. Use DBDL. Underline all PK, asterisk for FK. Okay, so the first part is the attributes. And then in week 12, okay, in week 12 will be the database. Okay, this is what we will cover in the tutorial. Okay, to design the code. Okay, to design the code, like in this example, design the code for a customer and then design a code for the order. Okay, order transaction. Components for the master file selected above. Explain each of the components which constitute the code design. Again, we will cover this in the second part of our lecture. And then for the data records, only for the 2 tables, minimum of 5 records, means you need to populate your table. I believe you can use Oracle for this. Yeah, so our lecture today will cover, last week we already covered week 13. So our lecture today will cover week 11 and week 12. So meaning as of today, then we have covered everything that is required for your case study. Okay. Let me close this. I hope you have your chapter 6 ready. Okay, because there are blanks for you to fill up. So shall we start?
Okay.
Okay.
Okay. Now, for database design, again, we are still in the design phase. And remember that the output or deliverable for system design is STS, System Design Specification. So far, we already have the input screen design, the report design, the FDD, and now we will add one more, which is the database design in our STS. So based on the design specification that is compiled in this document, STS document, then SA will pass this to the programmers so that they can start with the system development, means start doing the programming, coding, creating the necessary codes for that particular system. Okay, so the first thing is, I think you all can treat this as a recap on what you have learned last semester with Miss Teng. So I'll just go through very fast. What we see here in this slide is an example of a file. In this case, the employee file, whereby a file means a collection of records. In a DBMS, we also call it as a table. Okay, and then each one of these, we call it as a record, whereby it is a collection of related items of fields. Okay, so all these are fields. We have 1, 2, 3, 4, 5, 5 fields. Fields contains one logical unit of data of characters. So we will differentiate between the key fields and the non-key fields. The key field later we will cover what are the various keys that we have. Okay, and we why certain field in a file works as a key field and then there is a non-key field is that because we need this key field to do what? To differentiate one record from another. So if we have a payroll file, the key field could be the employee number. A customer file, the key field would be the customer number. And for a stock file or means the product or item, yeah, the key field would be the stock number. Now, as for the database concept, I believe you all, when you take a look at this picture, you can relate it with the database. Okay, so assuming that we have a file cabinet, so the file cabinet is in fact something like a database, right? And then when we check out one individual folder that represent a file, and we check out one particular card from the folder that is something like a record, and in each of these in this individual card, the element, the data element in this individual card, it's similar to a field in a database. Okay, now these are the types of keys that we will cover. We have primary key, and then there's a foreign key. There's also a secondary key, candidate key, and over here, I believe this is the associative entity or bridge entity, whereby it has the foreign keys from these two tables. And the student number and course ID is in fact a combination of the primary keys. Later we will see the difference between all these types of keys. Okay, the first one would be the PK. Primary key, the keyword would be it must be unique. Okay, it must be unique. Therefore, if you want to select a PK for your table, then find a field, or it can also be a combination of fields that can uniquely identify a particular record. Like here is book table, and I believe the book ID can be used to uniquely identify a particular book in a library. Okay, and for a student table, then each student has their own student ID. We can use the student ID to uniquely identify a student in a college. Next is the concatenated key. Here it is also known as the composite key or compound key. It depends. I believe, I'm not sure. What key do you call this in your database course? Where you combine the primary keys from two tables? Which term that you use? Is it also concatenated key? Or do you all use composite?
Composite.
Composite key. Okay, good. As long as we combine the primary keys from two tables, we call them as composite key, concatenated key, or a compound key. Like I believe this is the book loan table, whereby we want to identify which student borrowed which book. Okay, and then here is the date of the book borrowing, and then when the book will be written. It means that if you only have the student number without the book ID, we cannot use the student number to like uniquely identify this book loan transaction, because say this particular student 1034, we can see that there are two records, but then they are different, so we cannot just use one PK to identify each of the book loan transaction uniquely. That's why we must combine the primary keys from the two tables. Now, foreign key or FK, it is a field whereby it must match a primary key of another table. So assuming that you have this program table, so we have these are the program name, a degree in biology, degree in engineering, and so on. And then we have another table, which is a student table. These two are master table. Okay, master table. And then notice that for the student table, we have program code as well. This is to show that the student enroll into a certain program code. Okay, and then each of the program can be enrolled by many students. So this is the many relationship. That's why we have this program code as the FK. So this program code must match the primary key. Okay, the PK here will become FK in the student table. The reason is we want to have relationship. We want to establish relationship between these two tables. Now, you can find this question at the end of your slide, and I move it to this part because the question is relevant to what we have covered so far. So you can scroll down to the final slide. Okay, for this exercise, it is similar to question 1. Okay, similar to question 1. We can see there are 3 tables or 3 relations: the shipping, destination, and plan for a shipping database. So you are required to identify the primary keys and identify the foreign keys. Remember that a PK can be used to uniquely identify the record. So let me see. I think shipping is not a master file. Okay, it's more like a transaction file. Destination, yes, because I can see destination code and destination. So do you all agree destination code is should be the PK?
Yeah.
Okay, and plain, it's, I believe it's also a master file. Okay, a master file where in this table or relation we store all the plan records that they have in the shipping database, like the plan ID, number of seats in that plan, and the plan type. So among these three field, so I believe plan ID could be the PK, right? And how about the FK? It should be here.
Yes.
Like this is a transaction, right? Transaction file. So we have a shipping number as a PK, and this is matching with a PK in the destination file. So destination code can be the FK. I believe if this shipping table is a bridge entity, then I think we are missing one FK. Yeah, we are missing one FK. All right. So do you have the answer in your slide?
No answer.
Okay, then you can take down this answer. So it means that this is the associative entity or bridge entity, whereby this plan is assigned to many destinations, and each destination has been assigned by many plans. So it's a many-to-many relationship. So you have this shipping as a bridge entity. Since you have the shipping number as the PK, then to connect these two tables, then we have the one-to-many, many-to-one relationship. So that's why this is the FK. Both is the FK in the shipping. So have you all got the answer? Then I'll move on to the next slide. Okay. So the next one is the steps in database design. So we are now in the physical design. I add in a note here. Last week when we covered chapter 5, where we started the system design phase, one of the slides shows that ERD in the system analysis is in fact the logical design for database. Okay, ERD, in fact, we developed the ERD during the system analysis, not during system design. And when we proceed to the system design, okay, this is where, based on the ERD, based on the data dictionary, I believe you all know what is the data dictionary, then we will come up with the physical design for the database. Okay, so I want you all to notice this database design. Okay, is in the system design phase, and ERD is the logical design. Okay, in the system analysis. So the step starts from creating the initial ERD. Just to recap that we have covered ERD in chapter 3, system analysis. Okay, we come up with the initial ERD, and normally in initial ERD, we just list out our entities, and if there's a many-to-many relationship, it will not be resolved yet. Okay, this is the initial ERD. The second step would be for each of the entity that we have identified, then we will need to assign the data elements. Okay, normally we will just list out all the data elements that are necessary, means the one that we want to keep track for that particular table or entity. And then for each of the entity, we will assign the key field or the PK. And the reason for this is we want to ensure entity integrity. Now, entity integrity means each entity must have a primary key. This is very simple. Okay, primary key should be unique and cannot be null. All right, there are two more integrities that we will look later. So the first one here is the entity integrity. So from here, we have student and book, right? So we list out the data element for student. Okay, these are the attributes and assign student numbers the key field. For book table, we have all these attributes or data elements and assign book ID as the primary key. The third step in database design is to verify the data elements. This is where we make amendments, okay, which include resolving many-to-many relationship. And we have covered resolving of many-to-many relationship in chapter 3. So in this case, since we have many-to-many relationship, we will introduce the bridge entity or the associative entity, and we will end up with two pair of one-to-many relationship. Okay, so these are the two pair, one-to-many, many-to-one. Okay, so the many relationship should be at the associative entity. Also refer to our previous exercise, like exercise, okay, where destination code and plan ID will become the FK. So here we can see that the student number will become FK here, and the book ID will become FK here. One thing that I see here, the naming of the associative entity, borrow is a verb, so I think it's much more better to use a noun, perhaps loan, okay, means a book loan, right? Otherwise, if you cannot come up with a proper noun, then you just combine a student book, okay, student book. The next step is to relate the entities by using foreign keys. Okay, I've mentioned this in chapter 3 that we assign the FK to the relationship with the many sites. Okay, the two integrities that we'll check here is such. The first one is the referential integrity. It means the FK in one table must have a corresponding PK in a related table. So we have these to establish relationship between the two tables, yeah. And then continuation from this referential integrity, we must also check data integrity. Normally, sometimes we didn't realize and then we will somehow get this message when error message when we do our data entry. When we want to populate our table, we can unable to add in the value for the foreign key, because for data integrity, it means the foreign key values, okay, must have corresponding reference to the PK values of another entity. So it means that if say in this borrow associative entity, the student number here, okay, when you enter or populate the data, you enter student 1111. Okay, student number 1111, you will get error message if student 1111 is not in this particular student table. Okay, so that is data integrity. The FK values here must have corresponding reference to the PK values of another entity, right? So three integrities that we have covered. Next is the normalization. Okay, normalization. When we see here, I think this one should be normalized already. Okay, unless there's another any partial dependency or transitive dependency, name, address, city, state, no, book title, edition, publisher, author, year published. There's no publisher name, there's no author name. So I believe this is already in normalized form, unless there's a publisher ID and publisher name, then we can further normalize that particular table. Okay, look at second bullet. Normalization process will be simpler after we have done resolving of the many-to-many relationship. Okay, and then we need to list all of our data elements. So that's why just now I mentioned, is this a publisher name, or is this a publisher code, or have we finished listing all our data elements? If we decided that, oh, we need to have another, like keep track of all the publishers we have in the library, okay, then we might need to add in additional data elements. So further normalization need to be done. Okay. And then there's a note here. We do not have to normalize the data at its very crude means with the ERD, the data could now be either partially normalized or in some cases already in third normal form, which I have mentioned just now. Okay, student and borrow is definitely already normalized. And I think this is the final step, whereby once you have already normalized it, the last step would be to create the data dictionary entries. Okay, the data dictionary entries are what is needed, okay, in the system design phase, where we will design our database. Okay, now the entries here refers to all the data elements that we have in our table. Okay, for our data dictionary, normally we will have this description of our data elements by the tables that we have in our database. Here we need to use tools. Okay, example given here is Microsoft Access, but I believe since you all learn Oracle, then Oracle is one of the tools, not one of the tools, it is the tool that you will use for your case study. Okay, we will cover data dictionary in the next section, which is the data dictionary format. Okay, now so we have covered the 6 steps of database design. So now we talk a little bit about normalization. Normalization is the 5th step in the database design. Okay, this one you already know that this table with the 3 records, key field and non-key field. Okay, unnormalized data. Okay, what we will cover in SAD is something like a recap, just to summarize what you have learned in your database course last semester. Here I will not show the step. Okay, it's not included in our slide anyway, but just to give you all the difference between the UNF, first NF, second NF, and third NF. So UNF is the unnormalized data form, where we know that this is unnormalized data because I can clearly see these are the repeating groups. When you see repeating groups in a table, then it is in UNF, okay, unnormalized form. Now, to normalize, we will reach first normalized form, okay, first NF, when we eliminate the repeating group, means there is no more repeating group. We will reach second normalized form when each field will depend on the whole key. Okay, so if you have a combination of PK, then each field will depend on the combination of PK, not only part of the key. It means there is no partial dependency. And we can reach, we will reach that normal form where there is no transitive dependency. So what is transitive dependency? When there are no non-key depending on another non-key. Non-key depending on another non-key means your table is not in that normalized form yet. So if you eliminate that, there is no more transitive dependency, you are already in the third normal form. I think I mentioned transitive dependency when I talk about the publisher here. Okay, so assuming that you have publisher ID and publisher name. Okay, the publisher name depend on the publisher ID. Both are non-key attributes. So that is a transitive dependency. So we need to get rid of this transitive dependency. So we create another relation called publisher, and for the book, then we just put the publisher ID in the book, and we link it with the publisher PK in the publisher table. So that is a summary of the normalization technique from first normal form up to third normal form. I believe there's more than third normalized form up to BCNF, but I don't think we will cover that up until third normalized form. Okay, now in this slide we will look at the relationship between normalization and ERD. In fact, in the previous slide we have talked a little bit about this. Okay, for your information, that the normalization process in fact can be carried out without the entity modeling stage, meaning even if you didn't do the entity modeling stage, we can still do the normalization process. However, if we have done our ERD, means we started with ERD, our database would have been normalized already. Okay, so if you want to say like confirm, double confirm, a double assurance of making sure your tables are all normalized, then after the initial ERD, then you can perform the normalization as mentioned in the steps of database design, where the first step is we come up with the initial ERD, and in the fifth step of database design is the normalization. Okay, now normally after your ERD has been normalized, then you will get a final ERD lah. Okay, the final ERD is also where we have resolved many-to-many relationship. Notice that you need to do this for your case study. All right, the finalized ERD. Next, this is the continuation from the step 6 just now, the steps in database design, which is to create the data dictionary entries. And I've added some info here. Okay, after the ERD has been developed, the many-to-many relationship have been resolved with associative entity. The next step is the physical design stage. I mentioned this earlier on before I start my lecture, right? Okay, so what is a physical design? Okay, here it means we will have our physical database where we have several tables, and then our physical database will be created using our DBMS, okay, database management system, for example, the Oracle. Now, with the DBMS, the description of the database can be created. Description of the database, here we are referring to the data dictionary. Once we have that, then we can start entering data or populate our table with data. Just to give you all an idea where data dictionary comes in, again, in a much more clearer overview of the difference between a logical design and physical design in terms of creating our database. Okay. Now, you have this in your slide. This is the example of a data dictionary format where we specify the name of the field, and then we also specify the length, the type, okay, if there's any alias, other names, okay, and then we can add in description and any other information, perhaps if there's any preset values or default value, or is there any limitation, okay. This is using Microsoft Access. In my Office 2019, it doesn't include Access, so I cannot open my Access. But then for Microsoft 365, then need to activate. So I think I'm unable to show you Microsoft Access, so we just stick to the diagram shown here. For Microsoft Access, for each of the table, you can go to the design mode, where for each of the field here, then you can specify the data type and then the description. Then for each of the field, then you specify the size, the format, whether it's required, allowed zero length, index, and so on. Okay. Example of data dictionary tools, which is Microsoft Access. So I believe you know how to use your Oracle, yeah. Now, this is addition. I found this online. What you see here is an example of a table dictionary report. So table dictionary report for Microsoft Access table. Here, the name of the database is Northwind. If you see .accdb, that is a Microsoft Access database. Get table type access, the table name is customer. Now, what you see in this table dictionary report, it provides a detailed description for each of the Microsoft Access table. So what we see here is for one of the table, which is the customer table. So what we can see here is a table information like the number of records, okay, and then what else? The record size. Okay, these are the table properties and each of the fields here. So as a software developer in charge of the database, a report like this will give us all the information needed to understand the database design, and also in the future for system maintenance tasks. Okay. Now, What are the uses of a data dictionary? Here we will look at in the context of the SDLC, okay, System Development Life Cycle. During the system analysis, this is where, remember, one of the fact finding technique is document inspection or analysis of existing document. If the SA want to understand about more about the system, he can make use of the something like the table dictionary report. Go through the table dictionary report, then SA can get information about the data, and then he can use the report to ask question to the user, and also just as a reference, okay, as a reference, because we cannot memorize everything. And during the system design, this is where the data dictionary will be used to create our database, okay, for the new database, because a data dictionary is a source data about data. And during system implementation, so programmers, okay, in charge of the database will be using the same data dictionary working on the system. And the final phase in SDLC, which is during the system maintenance, this is in the future, perhaps 1 year later or 2 years later, they need to do some enhancement or additional of fields or addition tables into the database. Then data dictionary can serve as a reference tool, okay, to give the person in charge of the maintenance a very clear idea how the particular data element is used, right? Okay, so I believe we have done with the first part of our lecture. The second part is all about the code design. So let's take a break. Okay, I give a 10 minutes break and we'll continue.
Okay.
Hello, ladies and gentlemen. It's Swissman15 back with another episode of Noob School from Medieval 2 Total War. This is the second one. This will be basic cavalry tactics.
Hello everyone, it's an X here. I'm bringing to you a battle replay from Shogun 2 Total War. I am an X of Rhodes here, and we're playing against Miki Shokage. I just call him Miki for short. We decided to joke around a little bit. We had been doing a whole bunch of battles earlier, and we decided let's take all of our Yari let's just make a whole bunch of Yari cavalry on the other side and charge them at each other. So that's what we did here. Mickey's favorite unit is probably his Yari Cav. He makes it super fast so he can catch up with my general, and then I rage at the screen because his Yari Cav catches up with the general, and I can't deal with that. So anyways, I have here my general, and nothing but Yari cavalry. So that should be 10 units of Yari, of just regular generic Yari cavalry, no veterans at all. On his side, he's got, I believe he used some regular. No, he's got some of his. Popped them right about here. So then, by the time he got close, here they come. Oh, he's tried to do a flank here, but it wasn't quite enough.
Our general is in grave danger, my lord!
And already you can see, I mean, compare, I mean, this one stand.
In Rome 2, heavy cavalry, and more specifically heavy horse, made their barbarian factions very powerful together with their strong melee infantry, because these guys can hold their own against enemy cavalry. With Levi Freeman support, they become deadly against enemy cavalry, and they can also do a lot of damage to enemy cavalry. However, something came up that made me wonder, could Wedge be useful for something? Could Wedge in Rome 2 be useful against shock cavalry head on? Because I've never tried it myself. So here we have two Thessalians coming up against this heavy horse. On the charge, the Thessalians, let's just pause it here. Thessalians have a massive charge bonus of 67, while the heavy horse, they're down there at 39. Not bad for melee cavalry, but certainly not as good as the Thessalians. So on the charge, the Thessalians don't lose anything, while the heavy horse drop fairly rapidly. It will be interesting to see whether the heavy horse can come back from this. But over here in the wedge, I was a bit interested to see whether the same thing happens as in Attila, that the unit moves around and then comes back. But what you'll notice here is that the unit doesn't continue as far behind the other unit in Rome 2. So what happens is this Thessalian cavalry, let's see here, this Thessalian cavalry will still be able to impact fewer units. So the heavy horse lost about the same amount of men on the charge, but they should have taken significantly less impact damage. And it looks like they also were able to kill more Thessalians against shock cavalry head on, because I've never tried it myself. So here we have two Thessalians coming up against this heavy horse. On the charge, the Thessalians, let's just pause it here. Thessalians have a massive charge bonus of 67, while the heavy horse, they're down there at 39. Not bad for melee cavalry, but certainly not as good as the Thessalians. So on the charge, the Thessalians don't lose anything, while the heavy horse drop fairly rapidly. It will be interesting to see whether the heavy horse can come back from this. But over here in the wedge, I was a bit interested to see whether the same thing happens as in Attila, that the unit moves around and then comes back. But what you'll notice here is that the unit doesn't continue as far behind the other unit in Rome 2. So what happens is this Thessalian cavalry, let's see here, this Thessalian cavalry will still be able to impact fewer units. So the heavy horse lost about the same amount of men on the charge, but they should have taken significantly less impact damage. And it looks like they also were able to kill more Thessalians on the charge. Here the Thessalians are doing a great job in destroying the heavy horse. Now on a battlefield situation this would be different, because on the battlefield these Thessalians would probably get a precursor volley of 2 of Levi Freeman in the face. These fights would be supported, and in that case Epirus doesn't have the good support that Arverni has. Sure, they have Militia Hoplites, they're more expensive, they lack precursors. Very good for supporting cavalry fights, but then again, Militia Hoplites rush in to support the Epirus, and then Arverni.
I hope that you guys enjoyed the last episode videos. I really ask you, and italicized and added exclamation points to the word flanks because that's really important. If you can flank an enemy with your cav and get the entire army just to rout and flee the battle, it's a lot easier than killing them off one by one. And then roles which they will play, which is, well, heavy cavalry that can do powerful charges. They are good. They are my favorite type of cavalry, and I really like to use them. They can do. They're very well rounded. They can usually fight in melee well, and they can also take down enemy infantry like nothing. And they will always defeat enemy cav. Ask the enemy, really mess them up. I've used them. And then finally you have missile cavalry. I don't use missile cavalry, frankly, but I know the general tactics to use with them. You have Dvar, mounted crossbows, Genites, Vardariate, Vardariate, there you go, and Cossacks. They're all pretty good. Cossacks being pretty good at, and Var pretty good at melee, and also the very Vardariate. I can't say that. All right, I'm now going to show a few diagrams of basic. So what you can do is say you have the same equal amount of calves, archers, infantry, thinner lines than you will engage their flank more and defeat the infantry, which is always a nice thing to do. And later ones with the infantry will get surrounded and then rout. But I've seen other people do it, so I don't think they all took it from me. I frankly didn't copy someone doing it into the enemy infantry and pretty much smash them if they have no pikes. If there are pikes, do not do it. If there are pikes, just don't. It's horrible and you'll die. Don't do it. Do not do it, okay? So, the only other option that your enemy would have is to send his cav to counter your cav. If he doesn't, you will crush his infantry, lose very few cav, and then you'll probably win the battle from there. So it's a very, very useful tactic, but you have to get a nice charge off for it to work, and you have to have charge cav for it to work. Don't try to use melee cav for this, and don't try to use light cav for this. Oh, back. Right here. Oh, wrong way. Right here. If this unit right here, off in the corner, this cav of yours, this would be very good for an Allen Light cav unit or something like that. Light cavalry does this really well because they can run around fast and get there fast before your lines will break. Because if you're outnumbered, you might actually lose. Because quantity trumps quality. So remember that. All right, right here. So then, after you have charged in your your cavalry into their infantry, your infantry, get it. You have the cav. All right, the juke charge. So this is you have the which will try and go here. So what you got done, you never put your missile cavalry against the enemy archers because the enemy archers will kill your missile cav in no time. They will be done, gone, dead. Forget them. They're over. They're gone. They're not even worth. So missile cavalry tactic, which will help you in that fight. Off your missile cap, but you're this infantry over here. Quickly, I've seen it done. Following units. That's Gothic Knights and Lancers, Hungry Chivalric Knights because they are not good compared to the other ones, and Familia Ducale. Now let me explain. Gothic Knights are really expensive. They're for the Holy Roman Empire, and they don't perform well. They don't have a shield. And the same for the Lancers. They're for France. They cost good. They look good. Don't charge them pike. That's what. And you have some light cavalry that's fast. Never commit to it you think you might pull out, and then never leave them unused. I mean, sometimes I'm guilty of this where I forget the unit's there or something, but try and get your cav. The cav is the most important. You want to get them microed, you want to get the flanks, you want to use those tactics that I showed you. Get the hammer and anvil, get the gun that will benefit this. That a lot of
Then Arverni gets supported by Levy Freeman and Celtic Warriors, perhaps, so Arverni takes this engagement. But the heavy horse is losing here against the Thessalians. Over here, though, the unit is winning. Thessalians down to about 30 men. And over here they're also down to 30, but this engagement happened a lot sooner. So the Thessalians win with 30 men remaining. They could still do a lot of damage rear charging or charging into an enemy melee unit, stop an enemy charge. Over here, though, I'll just fast forward.
All
Over
right,
here,
so
the
let's
heavy horse.
continue. I'll start the second recording. And let me present my screen here. Okay, so the second part of our chapter 6 is on the code design, whereby we're going to design the code that is used to represent the key, especially the primary key. Okay, we're talking about the primary key because we use primary key to uniquely identify our record in a table. Now, we will start with a definition. What is a code design? Okay, since we are designing the code for the primary key, it means we want to represent our the record or the item in a table. So to represent the item, we can make use of a set of numbers as well as letters or characters. The reason is that when we have this code for our primary key, it will help us in identifying and also retrieval of the items of information that we want. Okay, and then when we design our code, there are two things that we need to focus on. Number one, optimum oriented use and also machine efficiency. Okay, let's continue. So the purpose of a code is unique, all right, uniqueness, whereby the definition of primary key that we have learned earlier on, where it is used to uniquely identify our record, right? So the code must be unique as well, so that it provides uniqueness to our record. And then another purpose is to reduce costs, because if you notice in our, which one is it? Our student table, we have the program code as a foreign key. We are storing the code, the program code instead of the long program name. Okay, so here codes can be stored instead of large details of data items, and this will reduce the storage cost. And number 3, ease of data entry, because the code is normally shorter than the description. Okay, so it reduces entry time and also any typing errors. All right, and also the cost of searching and entering data into the system. And another purpose of the code, it depends on what type of code design scheme that we use is to conceal information, meaning by just looking at the code, we know some kind of information from that. Means only those who know will know the information concealed in that particular primary key. Okay, example is a cipher code on a discount, meaning the salesperson looking at the discount code, he will know what does it mean. Is it a 5% discount? Is it a 20% discount? Depending on the code. Okay, so one of the code design that we will, the type of code that we will learn is the cipher code. So 4 purposes of code. Okay, for the types of code, we will cover 2 types. The first one is a significant code and the non-significant code. Now, example given here, this is an example of a code. Okay, primary key 54-501-306-34 If we say that this is a non-significant code, it means this is just a number. Okay, there's no other meaning behind these numbers. But if we are using significant code, it means this code contains certain amount of information, and then normally we will use a significant type of code when we want to design PK, primary key for master files. Okay, primary key for master files. So I hope for your the third tutorial question, okay, question 3, and also for your case study, you can decide on which type of code design to use by differentiating between PK for master files or PK for the transaction files. Okay, example, let me see. Example of a significant code that we'll cover under alphabetic would be significant alphabetic codes. And then for classification, we have 2 here, block sequence code and significant digit codes. We will cover this, okay, after this. And how about the non-significant? Non-significant means there's no meaningful information in the codes being designed. And normally we use this type of code design for the transaction files primary key. Okay, transaction file like the order transaction, sales order transaction. And one example is the sequence code like 1000, and then the next key would be 1001, 1002, and so on. Just in sequence, no certain amount of information included in that particular primary key. Now, besides a sequence code, significant alphabetic codes, block sequence code, and significant digit codes, we will also cover derivation codes and cipher codes. The information given for the significant and non-significant code is not in your slides, so you can do a screenshot of this slide for your reference when you do your case study assignment. Okay, so I'll continue with the next slide. Okay, we start with the first one, sequence code. From the name sequence code, it can be numbers, okay, it can be letters, and these numbers or letters, they are assigned in a specific order, meaning there's no other additional information other than the indication of the order of entry into the system. Therefore, when you use sequence code, it can be assigned automatically by the system. Okay, I believe you'll know in Oracle or in any DBMS, you can set it to auto-generating. Okay, example given here in a human resource information system, it issues the next employee number, consecutive employee numbers to identify their employees. Meaning 2056 means the number 2056 employee. Okay, this is a very clear example of a sequence code. Now, how about block sequence code? Okay, so here it is using blocks of numbers. Okay, like we have 110, 125. Okay, as long as this block of numbers start in the first digit is 1, it is signifying these courses are year 1 courses. Okay, 100 level courses, year 1 courses, whereby if the block of numbers start with 2, okay, 201 or 210, it indicates year 2 courses. So the difference here is that the sequence code, it just indicate order of entry into the system in sequence in a specific order. For a block sequence code, it is using blocks of number for what? For different classification. Okay. And the next one is a significant alphabetic codes. So you can see that the block sequence code, there is certain meaningful information, because by looking at the first digit, then we know whether it's meant for year 1 or year 2 or year 3 courses. There's a meaning behind it. Sequence code, it's a non-significant code, yeah. And then significant alphabetic codes, definitely a significant code, whereby based on the alphabet letters, we can distinguish or differentiate one item from another item based on either category like this. Okay, SW means software, HW means hardware, PL means plastics. Okay, code alphabet letters based on category. We also have significant alphabetic codes that is based on an abbreviation as well as a mnemonic code. Mnemonic code means easy to remember value. Okay, I added one slide here to show you example of using abbreviation. The first one here on the left side is the country. Okay, to represent country, we can use 2 letters, okay, as to represent the country. Like Malaysia, it's MY. Myanmar, it's MM. Philippines is PH. So notice that if you design your code to be 2 letters, then throughout your table, okay, to represent the country, you should use 2 letters to represent. Another example of significant alphabetic code is a mnemonic code. Okay, mnemonic code, it is an easy to remember value. All right, easy to remember value. Okay, I have this example like BGH. Okay, it's taken from the first letter of the hospital name, Buffalo General Hospital, BGH. Very easy to remember. ROS. Okay, here it doesn't represent the first letter of each of the hospital name. Okay, because there are 1, 2, 3, 4 words. Okay, so in this case, it uses the first 3 letters, ROS, ROS. So this is easier to remember as well. And then Ken, as in Kenmore Mercy, DEA, as in Deaconess Hospital. So there's some difference. All right, as long as it is easy to remember, whether it's the first 3 letters or the first letter from each word. And then notice that here the design is using 3 letters. Okay, so throughout here, the codes to represent the hospital names are using 3 letters, even though like Roswell Park Memorial Institute, there are 4 words here. Like Deaconess Hospital, Kenmore Mercy, only 2 words, but then we still remain the code as 3 letters code. Okay, so so far we have covered 3 types of codes. Okay, how about the next one? Significant digit code. Significant alphabetic codes, we are using alphabet letters, okay, to distinguish one item from another. For significant digit codes, we use subgroups of digits. Okay, subgroup of digits, a series of subgroup of digits. So I don't like this example because it doesn't represent the explanation given here. So instead, okay, I will use this example, 54-20-306-30. So this is using a series. Okay, these are series of subgroup of digits. So 1, 2, 3, 4. 4 groups of digits, whereby 54 is to represent the type of garment which is pant. Then 20 is to represent the attribute. For example, if 10 is short, then long is 20, something like that. Okay, and then to represent a specific color, in this case blue, I use a 306. Okay, this digit. Perhaps different colors will have a different digit that starts from say for various type of blue, then it will be in level 300. Okay, and then the final group of digit 30, this is to represent the sizes in inches. So I would like to change the example that we have in this slide. Okay, 5, 4, 20, 3, or 6, 30. So this is using a series of subgroups of digits to differentiate the items. So I hope by showing you this example, it is much more clearer. Okay, next one is derivation code. Now, derive means we get from something. Okay, so what happened is that we combine data from the item attributes or the characteristic of the that particular item. Okay, but then when we combine these item attributes, we choose those attributes that is stable, okay, not likely to change, like the date to create the customer code. Okay, customer code, we can add in the date join. Okay, means this is a member, something like a membership, and then a customer from which state of Malaysia. Okay, and then the type of customer. Here is wholesale, and then the name. 1, 2, 3, 4, 5. Okay, 5 letters. But then here your design must be consistent, right? So when you see a code like this, okay, this is definitely a significant code because there's certain meaning behind the code. We already know that the first, let me see, 1, 2, 3, 4, 5, 6, 7, 8. The first 8 digit represent the date of join, followed by from which state, followed by the type of customer and the customer name, right? So this is a very good example of a derivation code. And I think this is the last type of code, okay, which is cipher code. There's I think there's a mistake in your slide, so notice the one that is in black color. So that is the missing part. Now, why do we have this cipher code? Is that we want to make use of a certain keyword, okay, use a certain keyword to encode a number. Okay, a retail store, and this is a textbook example. So you don't go to any retail store and then, they're using camera. No, this is a textbook example. So I don't think in real life the retail store will use the same 10-letter word to encode their, say, the price. Okay, they might use other 10-letter word. But for our example, we will use this 10-letter word, campground. Okay, campground, C-A-M-P-G-R-O-U-N-D. It means here represent 1, A represent 2, this is 3, 4, 5, 6, 7, 8, 9, and this is 0. Okay, so we can say that this 10-letter word is used to code the wholesale prices. Okay, so if we have 562 ringgit and 90 cent, then it can be represented as GRAND. So only the retail store people will know that when they look at G, R, A, and D, it is in fact 562 ringgit 90 cents. Meaning only certain people will know the wholesale price for that particular item. And another example would be we can use cipher code to represent the percentage discount allowed. So meaning the salesperson will know that when he see the letter A, the discount allowed is up until 5%. So when he make his sales, then he knows that he should not exceed 5%. B represent 8% and so on. Okay, so the last type of code, cipher code, we use keyword to encode a number. Now, exercise for students. Similar to what we have in tutorial 6. Is it 6? Yeah. Question number 3, where you also need to suggest the code design or the code scheme. In this case, design the code for a customer number, purchase order number, and stock code for clothes. Okay, I add in additional info. We are assuming that the customer number is the PK for the customer master file, and the purchase order number is the PK for the purchase order transaction file. Purchase order is definitely not a master file, it's a transaction file. And then for the stock code, in this case, the stock is for clothing. Yeah, you will design the PK code for the stock master file. Okay, do you have the answer for this?
What the customer master file?
I mean, is it the answer provided in your slide?
No.
No, empty. You can, this one I added on. This is to give you idea. Remember my first slide where I explained the difference between significant code and non-significant code. Normally, when we design a code, we look at the PK. Is it a PK for a master file or a PK for a transaction file? If it's a PK for a transaction file, we can simply use sequence code. Okay, as simple as that. Just order of entry into the system, right? But then sometimes a student, they can also design a significant code for a purchase order because they want to add in additional information to the code that is designed. And then for the master file, normally we want to give some kind of meaning, like the customer number that we see here. Okay, the customer code. If you customer code is the PK for the customer master file, right? So we want to add in additional info about that particular customer. Then we can use this derivation code, right? So look at the example, the suggested answer. Okay, for a customer number, a suggested answer is to use sequence code. Example C0001. Okay, this is the simplest, right? But then there's no meaning behind this. It just means this customer is the first customer registered into the system, and the next customer entered into the system will be 0002. Okay, just a sequence code indicating order of entry. Alternative would be you can use derivation code. Okay, derivation code, whereby derivation code is a significant code with meaning. Now, to answer this type of question, you suggest the code, in this case, the sequence code, and give example. So you give example like this. Now, for purchase order number, purchase order is a transaction. Here, simplest would be just use a sequence code, okay, like P0001. But then my next question to students would be, is it sufficient? For a customer code, I believe this is sufficient. Like they can register up to 9,999 customers in that particular database. But then for a purchase order, I'm not sure that 0001 will be sufficient. It means the database can only store up to 9,999 purchase order. How about the following year, the next 2 years? So it seems that the database need to be updated each time. So I believe for the purchase order number, you can use longer digits, or you change it to become a significant code. Okay, a significant code whereby it will indicate, say, year of entry, not year of entry, year of transaction, okay, or is it meant for a certain particular category of purchase order transaction, and so on. Okay, and look at the third suggested answer for the stock master file. I make it clearer lah. Okay, it is a combination of significant alphabetic code and also significant digit code. You need to really understand this part. So if you have any question, you can ask me now. Because for your case study, you need to design this. Okay, the code for your PK. Now, the reason this, the first two, okay, is a significant alphabetic code, is that we use letters to distinguish different category of items. Like male category, we use MA. T-shirt category, we use TS. Remember, for the significant alphabetic code, you use letters. It can be based on category, based on abbreviation, based on mnemonic code, right? So I believe this is representing based on the category, right? And then the second half of the code here is a significant digit code, where it uses a series of subgroup of digit. Okay, so the first subgroup of digit represent the size, and the second subgroup of digit represent the serial number of the stock. Okay, this is one example where you can combine the two different code to come up with this particular code, MATS 17001. This is definitely a significant code because it contains meaning behind these letters and numbers. Alternative would be, you can use derivation code. Okay, derivation code. We have seen the customer code as an example earlier on. So far, any question on designing a code?
Miss, the master file refer to the table.
Yes, the table.
Oh, okay.
Like a customer file, we only keep information about the customer. So we call it as it's a master file. But then if the file is about a transaction, normally transaction is an associative entity where it is created when there's a many-to-many relationship, like purchase order. Customer place many order, and each order can be placed by many customer, or is it the order line? Okay, as long as it's a table that has foreign keys, okay, we need to create, if you don't want to rely on the foreign keys to become the what is it, composite key, you can still come up with a particular PK for it. In this case, I would say the purchase order is a transaction file. Okay, it's not a master file. The reason why I want to differentiate is this one, my first slide here. I added two additional info. Normally for significant code, we use it for this one, primary key for master files, where we want to have certain meaning into our code. But then for transaction files like order, it's very straightforward, very simple. If we just use sequence code, it is a non-significant code because there is no other meaning behind the code, just indicating the order of entry. Okay, just to give you some ideas, okay, on how to come up with the design, the code design, types of code. But then sometimes students, they want to provide meaning for their transaction files PK. I also accept it as long as they can justify properly lah. Okay. And for this particular example, this one, alternative, where for the stock code for cloth using derivation code, I have this example. I take this from my business student slide. Okay, my accounting student, they also learn information system. Look at the code by Zalora, yeah. Okay, the code ZA at 19AA78XZXJWMY. This is definitely a derivation code, but in this case, remember the purpose. One of the purpose of a code is conceal information. Okay, conceal information meaning some information can only be understood by the retailer themselves. So the comment that I give for this code design is it's unique and meaningful. However, it is not easily understood. I can only differentiate. If it's 78, it represents the color navy. If it's 79, it represents the color white. ZA perhaps is for Zalora. MY it's represent the country, Malaysia. Okay, it's unique and meaningful. Now, just to show you example of derivation code, right? Another example is from Sally Fashion. These two clothing, they are similar except for the color. This one is ivory, this one is blue. Okay, the code is KR045970. Okay, whereby these two pieces of clothing, they are sharing the same code, and the user will need to indicate what color they want. Is it ivory or blue? So I would say KR045970, this is concise and simple compared to this. Very long, quite longer than this particular code design. It's concise and concise and simple, but less meaningful. Perhaps this is simply a sequence number. Okay, this is a stock code number for 45,970 being entered into the system. So the next piece of clothing would be 45,971. Okay, it's less meaningful, and there's not much of info except for, okay, when I browse through, I can find that there's another clothing that with the same how many digit here? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. But then the first two letters are different. So we might say, okay, this clothing, they are from Korea, South Korea, and this one from Japan. Okay, it's concise, simple. I would say a combination of a sequence code and alphabetic significant alphabetic category of country, perhaps. So just to give you example of how we can also use derivation code for the stock code for clothes, right? Now, here I use the word unique, meaningful, okay, concise. There's a reason behind this, because I will cover the next one, which is the characteristics of a good code. Now, normally, when you design your code, design for your primary key, there must be a justification. Why do you design it in such a way? Do you want to focus on uniqueness? Do you want to focus on conciseness? All right. So these are some of the characteristics of a good code. Let's look at the first one, uniqueness. The code that you design must have only one value with a single meaning. It means you cannot use one code that represent two different items. Okay, so that is no longer unique. Next, flexibility. The code that you design should be easy to modify, especially this is needed when you want to reflect necessary changes. Example I've added here, the supplier suddenly the following month, they modified the way they number their product. So we need to change our code design in our own database. So in order to be flexible, it should be easy to modify. And conciseness, we can see this from this code. This is quite concise, whereby the code should require the fewest possible number of positions, okay, to include and define each item. Because when it is concise, it is easy to remember. Okay, when it is easy to remember, it's easy to enter it into the system. Easy to enter means less data entry error, less thing to enter into the system, so we use less memory storage. Okay, and stability. I remember when I covered derivation code just now, we combine the data characteristics of the item, and I did mention that we only use those attributes that is not likely to change, okay, because we want to have a code that do not require to be frequently updated. Like for the customer code, we use the date of join, because date of join it's fixed. Okay, it will not change. Instead, if you instead of date of join, you replace it with membership expire date. That is not stable because it can change. Like if it's it should be renewed every 2 years, then that particular characteristic, it is not stable, because a membership date expiry date can change from time to time, so it's not stable. That's why for a derivation code, you use data attributes that is not likely to change. Okay, if it's stable, then you are not required to change it from time to time, right? We want to have a code that is stable. Next, expandability. I mentioned this just now, like the purchase order. The code that you design must allow for growth, meaning we provide sufficient space for the entry of new items. Example, number of customers should grow. Okay, so if you only specify like customer number is C001, then I think you only expect like 999 customer only to be registered in your database. What if you have 1,000, more than 1,000 customers? Then it will not work, right? And besides number of customers, the number of transactions should be large as well. Okay, so your code should be expandable. And next one is simplicity. Simplicity means simple to apply, easily understood, especially for the data entry clerk with a little experience, or perhaps if it's an online system like online shopping system, then it's easier for them to understand. And finally, meaningfulness. Codes must be easy to remember, useful, convenient to use, easy to encode and interpret. Here, this is only applied to the significant code, the types of code that is under significant category. Now, if you compare between working with meaningful codes versus entering a series of meaningless numbers, I believe the last part would be it's not easy for you to understand. Okay, very long numbers if there is no meaning behind the numbers. But then if you can remember, or there's a meaning behind it, it's very easy to remember. Let's take your student ID, for example. Do you all remember your student ID? It starts with 2 digits, is it?
Oh yeah.
And 0, 20. Yours should start from 20. And then S for Sabah, right? And then what else? For bachelor, what is the letters after S?
MR.
MR. So MR. So M, I think, is for software development. R is for degree, is it? So yours is 20 SMR, correct me?
Right.
Okay, SMR, and then followed by the 5 digit, correct?
Right.
So the last 5 digit is in fact a sequence code, indicate the number, means you are, what's your number, yeah, Noel?
04988.
4988, meaning you are student number 4988 being entered into the system. Okay, indication of order of entry. Right, and then from the student ID, I know you're from Sabah, from the S letter, right? And then the MR represent the program that you enroll, which is the bachelor in software system development. Am I correct? Software development. I cannot remember. It's too long. What's the correct one? Software development, software system development, or system software development. I can only remember the diploma. Do you remember your bachelor degree program name? System software development or software system development?
Software system development.
Okay, so MR means is the bachelor in software system development. Okay, MR. Then you will be thinking, MR, how can it represent software system development? But then for a program, RSD is bachelor in software system development, RSD, and then we have RBU. RBU is a degree in business administration, and then we have RBK, degree in banking and finance. Then you will be wondering, what does BK represent in banking and finance? Then you must ask the SA involved in the designing of the code. There must be a reason, right? Is it based on category or is it based on abbreviation? I believe it's not the abbreviation because I cannot make sense from BK, from banking and finance. Right, software system development is RSD, SD, yeah, perhaps. Okay, so it's a bit, if we look here, is it simple, easily understood? No. I think they use concealing of information. Only those people involved in the development of our system, like they know what the meaning, how they design the code. But it's sufficient for us to know the first two digits represent the year of join, okay, followed by your from Sabah, and then the next two letters would be MR, right? M would be the your type of program, and R would be the degree. For diploma, it will be D, SMD, if I'm not mistaken, because D represent diploma. Okay. Yeah, I think we have covered the characteristics of a good code already. Now, it's almost 1:30. For the tutorial, we have question 1, 2, 3. So let's see question 5. What's our sequence of Farrell, Kelvin, Noel? So the next one would be starting from Noel. So question 1 would be Noel, and then followed by Kelvin. And question 3 should be for Farrell, rotating. Okay, so I think that's all for today. Any question before I end the class?
No. No question.
Okay, so see you on Thursday. Bye.
Okay. Okay, Miss. Thank you.
Welcome.